Hello everyone. This lecture is on linear and circular convolution. We have done linear convolution before and we have done circular convolution recently. So, if we want to compare these two or set a relation between these two, we should know some features. One, linear convolution. First, where linear convolution is applicable. Linear convolution is applicable. The first point is linear convolution is applicable for the sequences which are aperiodic in nature. Sorry, my writing is not good with this pen tablet. So, for aperiodic nature, we go for linear convolution. We go for linear convolution. Okay. Now, where we will apply circular convolution? We will apply circular convolution for a periodic sequence, but we take a finite duration of the periodic sequence. So, where we are going to take circular convolution? Circular convolution can only be applicable for periodic sequence sequences, but taking a finite so circular convolution is applicable when taking the periodic sequence but a finite duration of that sequence. Next is we know that in case of linear convolution, the two sequences can be of different length. Suppose one is of L length, another is of M length. Okay. So, what is the result? The result is, we all know for linear convolution, it is L plus M minus 1. This is the result of linear convolution, the length of the result of the linear convolution. Now, in case of circular convolution, the length of two sequences, we have to make them equal by padding 0. If there is a smaller sequence, we have to make it equal to the bigger sequence, the larger sequence, padding number of zeros. Okay. And in case of circular convolution, two methods are applicable: concentric circle method and matrix multiplication method. In two methods, the length of the two sequences must be same, and the result is also same, that of the length of the sequences. So, we are getting the same length if one is, that means for circular convolution, both of them must be of L length and the output is also of, suppose, L length. Now, in case of linear convolution, if we go for the third comparison, in case of linear convolution, we can, different methods are there. There are graphical methods, there are analytical methods, shifting methods, and different analytical methods are available. And in case of circular convolution, two distinct methods what we have prepared, that is, one is concentric circle method and another one is matrix multiplication method. Now, the next question comes, whether we can, from a linear convolution, can we get the result of circular convolution, or from a circular convolution can we go towards a linear convolution, whether it is possible or not. This is the next question. Yes, it is obviously possible. We can go from linear convolution towards circular and also from circular convolution towards linear. I am going to show you it with a numerical example in the next lecture. Thank you.